Hello students, I hope you all are well and studying maths for your first term examination. See, this is the third lesson and it's a very important lesson. Each and every theorem is important for 10th standard. So see students, I want you to be perfect in this lesson. So today I am going to take one theorem, that is perpendicular bisector theorem. It is from third lesson. So now see, what is this perpendicular bisector? Now previously we have studied in our previous standard 6th, 7th, we have studied that perpendicular bisector construction. So here I have drawn one segment AB. I have taken 10 centimeter, and if I draw a perpendicular bisector of it, how to draw? That more than half distance we are taking in the rounder and making the arc to both the side. And if I join it, I'll get perpendicular bisector of this AB. Now see how to identify this line is a perpendicular bisector. See, this L is a perpendicular bisector of AB. This we can identify, that means without construction, if the figure is given, how we will understand. So for that, these symbols help us. So this is a symbol of perpendicular, and these two symbols are the identical symbols. That means the segment from A to the line L and segment from B to the line L, that is, suppose if I give here M, that is AM and MB will be equal by the line, because of the line L. So this is called perpendicular bisector. This is a perpendicular symbol. This is bisector symbol. This identical marks are shown. So because of that, this line is called the perpendicular bisector. Now the theorem is depend on this perpendicular bisector. Let's see the statement of the theorem. So see what is the statement. See each and every word carefully. The statement is given: every point on the perpendicular bisector of a segment. Segment means this AB. Okay student, this segment is AB. It is also given in the textbook figure 3.40. So observe that every point on the perpendicular bisector. So how many points are there on this perpendicular bisector? This line L is a perpendicular bisector, and how many points you can observe on this line? See, think and tell me. See here, if I give here 1 point, and if I give the name here M1, second point if I give M2, third point if I give M3. So like this, because these are the points on the line. So my question is, how many points are there on this line L or on the perpendicular bisector? So the answer is there are infinite points. See, these points also we can say these points are on the line L, that is on the perpendicular bisector. So each and every perpendicular bisector has infinite points. So here what is the statement given? Each point. So out of this infinite points, every point, okay, what the statement is telling, every point on this line, see, on the perpendicular bisector of a segment is equidistant. So suppose if I take a point here P, any name you can give, and if I join this AP and PB, see the figure is shown in the textbook. So if I take any point P on the line L, and if I join with A and B, that means what I get, this AP and PB will be equal. This is the statement of the theorem. See, is equidistant. This point is P is equidistant from the end points. End points means AB. AB are the end points of segment AB. So from the end points of the segment. So from this statement, now we have to find the given. So what is given here? Perpendicular bisector is given. So what is the name of the perpendicular bisector? Name of the perpendicular bisector is line L. So here we'll see line L is the perpendicular bisector of segment AB. According to the figure only, we will convert this statement and write it down in the given. So line L is the perpendicular bisector of segment AB, at point M. So this is only the description of this figure. Point P is any point on the line L. So this statement we'll write with the help of our theorem statement. Now what to prove? We have to prove that these are equidistant from the endpoints. That means what segment we got? AP and PB. So we have to show that here PA is equal to PB. So for that, see, construction, we have drawn PA and PB. Why this is given in the construction? Because this about this segment PA and PB, it is not mentioned in the statement. So that will be in the construction. Draw segment AP and PB. Why we are drawing? Because this theorem is based on the triangles. So we have to convert this figure into the triangle. So if we join this, we got the two triangles, that is triangle PMA and triangle PMB. So now let's start our main part of the theorem, that is called proof. So here we'll see the proof, that is in triangle PMA and triangle PMB. What you can observe? You have to observe the identical marks and say what the things are congruent. Which things you can see here congruent. So here, see, PM is congruent to PM. This segment is same in the measurement. So, and this is common in both the triangle. PM is common in this triangle also and PM is there in this triangle also. So their measurement is obviously same. So we'll write first seg PM is congruent to seg PM. The reason is it is a common side. Second, angle PMA, angle PMB, both are congruent. Why? Because each is a right angle. We can observe with the symbol. Now seg PAM and seg BM both are congruent because it is given already. So these three things we got from the observation of the figure. So we can say triangle PMA and triangle PMB, both the triangles are congruent. By which test? By the SAS test. Okay, in the figure also you can say side angle side test. So with these two tests, with this test we can show that the triangles are congruent. So see, here it is shown that triangle PMA congruent to triangle PMB because of SAS test. Therefore, seg PA is congruent to seg PB because the triangles are congruent, so their corresponding sides also congruent. So we'll say the reason CSCT, congruent sides of congruent triangles. And now therefore this segment will convert into length. So length of PA equal to length of PB. So see students, always remember that when seg will come, that time your congruent symbol will be there. And when the length we are telling, that time compulsory equal sign. So see, hence every point on the perpendicular bisector of the segment is equidistant from the end points of the segment. So this way you have to learn your theorems properly. Thank you.